All right, I guess we'll get started. I feel like that 2 minutes is like the perfect amount to wait for like the people that are straggling behind to show up. It's like the perfect amount. So I have to wait those extra 2 minutes. I realize they're painful. You're watching the clocks like slowly tick till it hits 4:02. Well, it's painful for me because I'm ready to go. But yeah, I gotta. Yeah, it's like the countdown to doomsday. Actually, I suffer from like severe anxiety when I talk in front of people. You wouldn't notice it. I have to almost like gear myself up. I need like a good hour before I teach so that when I teach, I don't like stutter over my own words or pass out on the floor. So that's what I need in order to be ready. Some people just need that extra 2 minutes before they can show up. All right, so last week we talked about variables. We talked about a lot of things, right? We kind of like, I hit you with a ton of information all at once. But it's okay because you're going to be using variables constantly between last week until we hit week 14. Actually, you'll be using variables likely through your entire career, right? Because you need them. So yeah, we talked about variables. We did a few different things. We wrote some stuff to the screen. But for the most part, we did a lot of stuff to the console itself. Now, we didn't, unfortunately, finish week two's lesson. Week two's lesson requires us to go over strings and numbers, which we'll do in the first hour today. And then that'll be it. We'll be done week 2. And then we'll move on to week 3. And hopefully we'll get through week 3. Week 3 is a little shorter. I did it intentionally because the other group is actually behind as well, just by 1 hour. So it should kind of balance itself out, which means when we finally hit the midterm in week 7, everybody will be caught up. And everybody can do that midterm that week. Let's kill that volume. All right. The other thing is week 3 is lab week. Every 3 weeks we do a lab. This week is the first lab. I'll present that towards the end of the class. It's easy, should take you maybe at tops an hour. But for the most part, it should be fairly straightforward and easy to do. And it's fun. Well, I hope it's fun. Obviously, that's objective. But other than that, for today, we'll finish off numbers and strings. And then we're going to talk about arrays. And then we're going to build a tic-tac-toe game. And if we have some time, we'll even implement an opponent, like a computer-based opponent. So we'll see. I like the woo over here. That's pretty awesome. All right. Okay, so if you want to, there's a couple things we could do here. Do we need variables in place? We don't. If we go to our weekly learning, now you can start with what you had last week. That's totally cool. If you don't have anything, though, go to week 2 and download the variables numbers and strings starter files. And go ahead and save that wherever you're going to work from. I'm just going to save it right on my desktop. And then I'm going to extract it. And then I'm going to open up my IDE. I'm using Sublime. You guys are welcome to use whatever you want. Hopefully by this point you have an IDE that you give preferred treatment to that you kind of like. I'm going to go ahead and open up that folder inside my IDE. There we go. And the file we completed last week was variables.js. If you weren't here last week for any reason, one, you can go to YouTube. I have both Thursday's class and Tuesday's class posted to YouTube. I've posted both links under the weekly learning. Every time I record a lesson, I will post it underneath the weekly learning, the link to YouTube. Otherwise, I would subscribe, and then you'll automatically get an email notification letting you know. If you're looking for the code, the completed code, where do we find it? GitHub, exactly. The GitHub. You should be already following me on GitHub, so that way you can get the up-to-date completed code directly from GitHub and kind of cross-compare. So if you miss a class and you're following along on YouTube and you need support, that's a great place to start from, is to download the completed code and compare it. Okay? Otherwise, show up and everything will be cool. Okay, so we're not going to work in variables.js because we have done that. It is complete. We are going to work on numbers.js. And I'm going to stick this one over to the left, sorry. That one over to the right. And I'm going to open up this project inside Google. And I've updated Google, and they've decided to go with the nice rounded look in their latest update. It's almost like a complete GUI overhaul. Yeah, exactly. We've only been pushing for material design for how long, and now we're just going to make everything round. Yeah, whatever. All right, desktop. And open up the index.html file. That should open up for you. I'm going to decrease the size to human level. Open up the console and shove that towards the bottom. I need to set up, you can actually create like aliases in Chrome, and you can set up all your settings and features under an alias and then switch back and forth between the aliases. I need one for work and one for here. This one looks like I'm a senior citizen, and everything needs to be massive for me to see it. Not that the one at work is that much different, to be honest, but all right. Okay, I'm going to, so I have the, what is this called? Numbers.js file open inside my IDE, and I've got the console open on the left hand, or on the right hand side for me. Your left, my right. Cool. First thing I want to do, I want to be able to output information to right here inside the numbers. I created a handy little function to do that. It's called numDisplay. Seems kind of on the nose, but whatever, it works. If you need explanation of what this function is doing, feel free to ask me later, maybe at the break. But for now, just suffice to say that it will take content and put it to the string for us. Okay? So the one thing we do need to do, though, is we need to actually select the numbers section so that I can store information into that section. So we're going to do that now. So we'll use the let scope modifier. We're going to call our variable numl. And to select an element on the page, does anybody remember what method we call? I know, it's been a whole week. Query selector. It was on the tip of your tongues, I know it. Numbers, and we just use a CSS selector to actually grab that element. And that's going to return back an object, one of the document object models. That will return it back and store it in numl. And if you were to take a look at it, it's an instance of HTML object, incidentally. Don't worry, we're going to get more into objects and stuff like that in the coming weeks. All right. So the first thing we're going to talk about with numbers, we should talk a little bit and remind you about the data types. So does JavaScript have floats, doubles, and integers as primitive? No, it doesn't. What is its primitive data type when dealing with numbers? Just number. Just flat out number. That is correct. There are methods in the JavaScript API that allow you to create specific things, such as, you know, an 8-bit number or a integer or a float or something specific, but it's so obscure and it's not something you're generally going to encounter. So for the most part, just suffice it to say, the primitive data type that we have available to us to deal with numbers is called numbers. If we want to deal with strings, it's called string, right? We don't have character available to us. We have string, okay? And then if we want to deal with objects and arrays, those are also primitive data types as well. And then we have one other one that I didn't mention. Does anybody remember the very common primitive data type available in every language? Const is a modifier. What's that? Boolean. Boolean. Yeah, exactly. I say Boolean. I love it when people say it properly because Boolean is proper. And yeah, I say Boolean. All right. Anyways, we're going to do some arithmetic. Don't get nervous. It's easy. So let addition equal 5 plus 5. And the way this wonderful function works, we just go numDisplay. We'll give it a label. I'm going to call it subtraction. Or sorry, addition, not subtraction. How many of you wrote down subtraction? And then we're going to call the variable that I set. I feel like this is not quite large enough for you to see. There we go. That's a little better probably. And then if you refresh your browser, you'll see it spit out the addition statement equals 10, which is correct. 5 plus 5 does equal 10, right? Last week we talked about variable modifiers, right? The variable modifiers, their purpose is to create scope for us. They define scope of our variable. Does anybody remember what let is scope to? Yes. Yes, scope to a block. So what is a block? How do we know what a block is? There's defining syntax that tells us what a block is. Yeah?
Is it the curly braces?
That's exactly it. The curly braces define a block. And believe it or not, in JavaScript, you can actually just write curly braces. You don't need a for statement. You don't need if, else, anything else. You can just write straight up curly braces and stick code right in between them, and you will scope them. You will scope your code to inside those curly braces. All right? It's not done often, but it is on occasion. People do it. Okay? Cool. Let's do a subtraction. If we can spell words. 10 minus 5. Num display. Subtraction. Subtraction. Whoops, not colon, semicolon. Just going to get rid of the warnings and info and verbose. There we go. Now it's a little cleaner of a concept. And when you refresh, you can see the subtraction statement equals 5, right? Because 10 minus 5 is 5. This is nothing new, right? You guys have learned arithmetic operators. You would have did it in your intro to programming class. You've likely have built, more than likely, a bank app. How many of you guys had to build like a banking application in one of your programming classes? No? Really? That's like the go-to example for most instructors. Let's talk about checking and savings accounts and stuff like that. Yeah, not very many people do games and stuff like that, but yeah, some do. But that's like the go-to. So, but you guys have interacted with the arithmetic operators, right? You've done subtractions, you've done additions, you've done multiplication, right? They're all basically the same. There's nothing really any different, except for maybe the syntax is a little different, but the operators themselves are the same syntax as ever. So why don't we create a variable called letArithmetic? Did I spell that right? Yeah, arithmetic. And we'll just we'll practice with some of these. So 10 times, which is the asterisk, 5 num display. I'm just going to call this arithmetic. Arithmetic. And we'll refresh over here, and sure enough, arithmetic statement equals 50. So if I want to multiply things, I use the asterisk, right? If I want to divide it, so I want to divide 10 by 5, I can just use the, is it the forward slash? It's the forward slash, right? It's the direction it's leaning in, right? So forward slash, that's a division question, right? Equals 2, because 10 divided by 5 is equal to 2. Here's one that not many people know, but it's very handy. What is this operator?
Modulus.
Yeah, that's the modulus, and what's its purpose?
To find the remainder.
That's correct. It takes the division question, it does the division, and returns back the remainder. So in this scenario, 10 modulus 5 would be equal to what?
0.
Right. And if I change 5 to 3, that's right. It will be equal to 1 because 3 goes into 10 3 times, and we get 1 remainder. That's what gets returned back to us. Cool. Incidentally, in JavaScript, because it's a loose language, it will try to cast things for you based on what it thinks you mean. It doesn't always work, and it's not always reliable. This is part of the reason why some JavaScript programmers lean towards something like TypeScript, which is a pre-processing language that provides data types to JavaScript and makes it more strictly typed. Some people like the strictness. They prefer it, right? Other JavaScript programmers, they don't really care. They've learned to work past these little idiosyncrasies that are built into JavaScript. Let me show you an example. Let add string equals, let's take a quoted 5 and add it to an integer 5. And then we'll num display string math add string. Now if I refresh, what am I going to get on my display? How many people say 5, 5, 55? 3 of you? How many think 10? Okay. So this is one of those times that the looseness actually gets broken. If I refresh, we get 55. And the reason why is because the plus sign, it's a dual function inside JavaScript. Okay? It does double duty. The first duty is to add two things together. The second duty, does anybody know what the second duty of that thing is? Yeah. Concatenation, exactly. So what it does is it assesses the equation, it assesses the expression, and if there is a string inside that expression, it assumes that you want to cast everything to string and then add it all together, which means concatenate, right? So it doesn't even matter which side I put this on. If I take out the 5, put integer 5 and do plus, and then refresh, I will still get 55. Because the whole expression gets evaluated, and then the appropriate method gets called. Under the hood, there's very likely an overloaded method. It assesses the fact that we're passing it into a string as one of the arguments, and then it just calls the concatenation method as opposed to calling the addition method, right? So that's not very reliable. However, everything changes the second we change this plus sign operator into a minus sign. That gives us 0, right? Multiplication, that gives us 25. Division, we get 1. And modulus gives us 0. So all the other arithmetic operators work as expected, just not the addition. So what we do generally, if we're not totally sure that the number we've gotten is a number and not a string, and we are going to perform addition, or actually any math for the most part, we do have the ability to cast it. We can force it to become a number, and we can do that by calling number, which is a function, and we wrap our string 5 inside number. Now when we refresh, we get 10, and everything functions as normal. And the only reason that's happening is because we're first casting it to an integer and then adding it onto 5, right? So that is a bit of a gotcha that you have to pay attention to. Now I know you guys have done programming in PHP. That doesn't happen in PHP. You can take 5 and add it to 5 and all day long. It doesn't care. But that's because PHP's concatenating character is not the plus sign operator, right? It's the dot. It's the period. That's how they do concatenation. In Ruby, it'll blow up and tell you you're an idiot and stop trying to add strings to numbers. Is essentially what you get back. So you got to fix that. It also doesn't let you add, well, it will let you add floats and stuff like that, but you won't get the expected result unless you turn everything into a float. Same as you would be with C++ or any very strict language. All right, cool. So that's our wonderful, warning message about strings with arithmetic. Let's talk about a little bit about floats. I'm sure you've already encountered this. Let's do let my float equals 0.2 plus 0.1. And then we'll display that out. My float. Now, before I refresh my browser, what's it equal?
Is this a trick question?
It is very much a trick question.
Oh.
We've already started talking. You might as well finish it.
0.
0?
Is it gonna put
He
out
says
0?
he thinks 0. Okay, let's take a show of hands. How many people say 0? How many people think 0.3? How many people think 0.3000000000004?
Yeah, probably. Why would you say that?
That's a good question, right? Why would I say that? Unless that's likely the answer. Does anybody know why this happens? And computers are stupid is not the answer.
Because we didn't say what the precision was.
Yeah, but if we take, like, if we did this by pen and paper, even on our calculator, right? Take a calculator on your phone. Don't even pretend you don't have a phone. Everybody in here has one, I bet. All right, so if I take 0.2 and I add it to 0.1, I get 0.3 on my calculator. That's because the wonderful people that built this app were like, floating point notation is stupid, and we need to fix things in order to give you a proper number. So computers calculate using floating point notation. And to a computer, 0.3, 0.1 plus 0.2, because of the way everything is done in binary, will not equal 0.3 exactly. It uses floating point notation in order to add the two numbers together, which results in a very bizarre number. Okay? Don't ask me how to do the math. It's called 2's complement, in case you ever want to research it. Read that 2,000 word Wikipedia ad. The easiest way to deal with this type of stuff, and it's very common, especially if you're working with banking applications, is either A, to use a library called Big Decimal, which will deal with stuff like this and try to normalize your data a bit. Or, does anybody know the other way?
Rounded?
Kind of round it. Yeah, you could if you knew.
Yeah.
You can truncate it, but in JavaScript, they don't have a truncate. You have to round. You'd have to cut it off with the rounding. What's that?
Floor.
You could floor it, but floor it's not necessarily what you want to do. Because it would always result in the lesser, right? Which people get mad when they're trying to add money to their account and you're rounding down every single time. Yeah. No, so generally what a lot of people will do is they'll convert it to an integer. And so they just increase it, multiply it to whatever it takes to in order to present an integer, do the math with the whole number, and then convert it back to the decimal place afterwards. So I can show you what that looks like. So if we take my float,
There's got to be a better.
this is literally one of the most common ways to do it. So first we're going to create some brackets, right? Because BEDMAS. For those of you that don't know what BEDMAS stands for, it's brackets, exponents, division, multiplication, addition, and subtraction. It's the order of operations, right? In the 90s, it was BEDMAS. Now I think it's something else. All right, we're going to create two sets of parentheses. We're going to do 0.2 times 10. That way we're converting the 0.2 to 20. Or no, to 2, sorry. Then we're going to add 0.1 times 10. That whole equation, when it's finished, is going to get divided by 10. Now we might as well just duplicate this wonderful line up here and bring it down below our float. Incidentally, in Sublime, it's Command-Shift-D if you're on a Mac, Control-Shift-D if you're on Windows to duplicate the line. To move it, in Mac, it's Command-Control. Yeah, Command-Control and up and down, and it will move the line up and down. And in Windows, I don't know. You'll have to figure it out. All right, now if I refresh, I get 0.3 properly. Like I said, there are libraries that deal with normalization with numbers, and more people will adopt the library than to deal with that, right? Much easier. All right, cool. Something you didn't quite know. Hopefully this is also something you don't necessarily know. We're going to increment and decrement numbers. So first I'm going to start with a number. We'll start with 5. And then I'm just going to spit that right out to the display. Increment. And I'm going to add plus plus to it. And wham. What is the value of 5 on the display? What will the value of 5 be on the display? 6. How many people say 6? How many people say 5? Cool. It is 5. Why does that happen?
If you put And
Yep.
it'll add beforehand. If you put them after, then it'll add after.
Exactly. It's an order of operations issue. So what happens is we have passed increment as an argument to num display. It's like, that's cool. I'm going to now display that out to the browser. Then you've asked it to be incremented. So it's like, I'm going to output that to the browser, and then I'm going to increment it. Which means if we were to write directly after that, duplicate the same line, my float here will be, am I in the right spot? Nope, totally wrong spot. Let's go to the other line. Let's duplicate the correct line. The increment here will be 5. The increment here will be 6. Let's just knock off those 2 plus signs on that line because we don't need them. There we go. If we refresh, you can see. And the reason is because num display outputs the increment value and then increments it. And then the next time we call it, because the incrementation has happened, it's now 6. Let's do one more. As the gentleman over here said, what's your name?
Steve.
As Steve pointed out before, because this is after increment, it doesn't happen until after increment has been used within the function. But now, because we're calling it before, this is almost the equivalence as if we wrapped it in parentheses and added +1. And as we know, based on order of operations, anything wrapped in parentheses is evaluated before anything else, right? That's how that works. So what's happening here is it's going to increment, then pass the value that it ends with to the function, and then it'll be output to the screen. So if all is golden, pony boy, it'll be 7. You have likely never, ever encountered this. And the reason why you've likely never, ever, ever encountered it is because we generally will do let increment equal 5, increment plus plus, then num display, that's normally how we do things. Most programmers work this way. I'd say about 90% of programmers do it in this order. It's very, very rare that a programmer will increment in line with another function. It's just not done. You just normally don't do it. So it's not something that you're likely going to encounter. But be aware of it because it is a thing that can be a bit of a gotcha, especially if you're trying to do something in line like incrementing in order to do like a loop or anything like that. It can definitely catch you up. All right?
So don't do that.
No, you can. It's totally legit. Just remember that depending on what you want to happen, you need to make sure the plus signs are in the correct order. So the same thing occurs with decrement. I'm not going to rewrite this out. I'm just going to change these to decrement. Refresh, and you can see the same issue happens. Starts with 6, it outputs 6, then it decrements, then we go to 5, then we decrement, and then we output, and now we're at 4. Clear as mud? Clear as mud. Awesome. All right, let's do comparison operators, because those are always fun. You know what comparison operators are. You've encountered these a bajillion times. Let's create a variable called comparison. Here, why don't we do something a little bit more enjoyable? I'm going to give you 2 numbers. Because you know what comparison operators are at this point. How do I make that equal true?
Oh,
What symbol do I use to make that equal true?
greater than.
Sure, greater than. What else could I use? There's 2 that would be completely legitimate.
Not equal. Not equal.
Yeah, not equal totally works as well. Why don't we duplicate that and do not equals? That looks like this, right? What's another one?
Greater than or equal to.
Greater than or equal to. That's another one as well. Oh, that's not it. There we go. No, stop things. There we go. Nope. There we go. I had it right the first time. All right, let's do another one. How do I make that true? Yep, less than. Less than symbol works. Yep, not equal to also works. You mean less than or equal to? Yeah, I kind of felt I knew where you were going with that. Yeah. Less than or equal to. What about how do I make that true?
Two equal signs?
Two equal signs, right? Why two?
Yes. The third one compares to the other type as well.
That's right. They're one. So there's another one. There's another comparison that we can do that is also a valid comparison to get it to equal true.
It's not with three equal signs.
You're so close.
What is it?
It's not with two equal signs.
No.
Yeah, you're only allowed 3 operators. You don't get 4. Not in a row. Yeah, that is also equal to true. And then incidentally, if we wanted to make 6 and 6 compared, what is the valid comparison? There's 2. Double work.
Three equal signs.
2 equal signs, yeah,
Three equal signs.
and 3 equal signs. That is correct. So that, ladies and gentlemen, is all of your comparison operators. Right? You're pretty used to that. You've seen comparison operators before. So there's something else that's a little bit different. These are logical operators that we're going to take a look at. Logical operators. A lot of people are used to using these in if conditions only. And not many people know that you're not constrained to just using logical operators within an if condition. You can actually use logical operators outside of if conditions entirely. In Ruby, for example, we have this really cool thing. So if I had like this, then I can do something later on like this. And what that produces is let bool equal true. And then the thing underneath says take bool, compare bool, see if it's true, and if it is, return that. If it isn't, return what's ever on the right side. Now, unfortunately, I don't think we have that available to us in JavaScript. Let me check real fast if we do, because that would be freaking awesome if we did. No, yeah. So unfortunately, you don't have that in JavaScript. But what you do have in JavaScript, you just write it out a little longer. Looks like that.
What's that? Sorry.
And then, let me just output it here, and then I'll walk you through what it is. Statement equals true. The way this works, it's like a normal if condition, right? If I was to write this as an if condition in the long form, it would look like this. If bool equals true, return bool, else return 5. That's what that statement is essentially doing in a lot less characters. It takes the left side, and if the left side is true and is not false, undefined, or null, then it will return it. If it meets any of the other negative criteria, false, undefined, or null, then it will return the right side, which is 5. And we can demonstrate that. Right now we have the bool statement equals true. If I change the value from true to false, and then refresh, whoops, what did I do here? Oh, yeah, it doesn't like my if condition that I wrote as an example. There we go. Now we get the bool statement equals 5. And that's because it evaluated the statement and it said, no, there's nothing there. That's undefined or false or 0. There's something wrong with it. So instead, I'll return back 5 to you. And I believe it's a strict operation. I think if I change this to 0, we will get 0 back. Here. No. So you got to be careful with that one. 0 does evaluate as false. So you have to be a little cautious with that one. There's also the, yeah. Sure. So the way it works is the OR operator compares the left and right hand sides. If the left side is true, it will return that. So if it's true, if it's not 0, undefined, null, or false, it will return the left hand side. If it is null, undefined, false, or 0, it will return the right hand side instead. Does that make sense? So again, it's the equivalence to writing this as this. If bool equals true, return bool, else return 5. It's the equivalence to that. Does that make sense?
Do you know the condition statement in C++? So question mark 10.
Yeah, the ternary. Comparative to a ternary, it would be that's what it would be in a ternary. Ah, there we go. The light clicked on. I saw it. Yeah. You got bright and glowy there for a second. Yeah. Yeah. It's not something that is common, but you'll find that programmers that have been programming for a long time, they will use these little shortcuts all over the place, and they are the thing, to put it as frank as possible, that will fuck you up. Because it's the thing you're not expecting, and you don't know what it's doing, but you just need to look at it as if it was in an if condition. If it was an if condition and it was your condition statement inside, it makes perfect sense, right? I'm just comparing bool. Is bool true? Yep. Cool, then return it back. If it's not, nope, we're going to return back 5, right? So let's see if you can monkey your way through this one. This one's a little bit hard too. All right, so we'll change bool equal to bool double ampersand 5. And then we'll change bool to true. Let's duplicate this one, bring it down. There we go. What do you think bool is going to return? How many say true? Okay. How many say 5? One person? Okay. Why do you think 5? You're on the right track. It is 5. It will return 5. The reason it will return 5 is because it compares the left-hand number, right? Whatever the value is on the left, and it looks for it to be true. Think of how an if condition works, right? The if condition only executes with an ampersand sign in between the two conditions if both conditions are true, right? So if I was to write this as an if condition, if bool equals true and 5 is essentially what I'm writing here. Which 5 will be true, because it's not 0, it's not undefined, it's not null, right? So it will be true. Then, what am I doing? Then return 5 is essentially what's happening. So what the comparison operator will do is it will compare the left-hand side and the right-hand side, and if both sides are valued to true, it will return the right. That's how it works. As a ternary statement, let me think about it. Bool equals oops. That's essentially what it looks like if you did it that way. Yeah.
May I ask you, common practice that people use this shortcuts like during, working companies or teams forever?
Yeah, so this one you'll very rarely see. I've seen it once in like 2 months, last 2 months, and I work next on code. This one, very common, extremely common. And the reason why it's extremely common is because when we're dealing with large amounts of, say you have a list of options, say you built a plugin, right? And you're able to take in a list of options to turn things on or turn things on, right? You can actually iterate through your list of options. And then you can compare them back and forth. And if you have default values, you can use this operator to either load the option that was selected or the default value. And you just keep going back and forth through your whole list. Very, very handy. A lot handier than running if conditions on every single one of those options.
So like, as much as I try to think about it, like how to write it without if statements, like the more my mind just goes off.
It's one of those logical operator things that is not necessarily going to show up on a test, so don't get nervous. But I feel it's one of those things that's very key to know. Yeah.
Isn't that like when we already check the sample and pipe switch?
No, it'll do the left-hand evaluation first, and then it will do the right-hand evaluation. It doesn't really matter.
But then the result of that is going to be switched. So is that true?
Yes, no, you are 100% correct. Yeah, that is a mistake. Nice catch. That is 100%. Which one is it here? It would return 5. And then bool. Actually, it wouldn't even return bool. It would return false. It won't return bool. It will return false. Because if this is false, if either side of this is false, it returns false. Okay? Don't get hung up on the ampersands. Like I said, they don't show up very often. Like very, very rarely, you'll get a programmer that'll use the double ampersands. But the double, like the or symbol, that shows up all the time, especially in JavaScript. Yeah.
Why would this be used? Like, I understand the
Yep.
bar thing, but
Let me show you. So I have a plugin that accepts an options as an argument, which is really cool. So in JavaScript, I can actually pass an entire object as an argument to my function. This is very common. You will see this all the time, especially if my plugin allows for things to be turned on or turned off. If you want an example, you can think of something like, if you're doing web development, I use this all the time. I really, really like BX Slider. This is BX Slider. It's a cool little library. Allows you to do a lot of different things, but they're all carousels, essentially, right? However, they have all these wonderful options. There's about maybe 30 of them, I think. Just shy of 30. Imagine that function call. Imagine if that was a function. Function, not only does the person have to know what the function name is, now they also need to know the order of parameters. And you've got 30 parameters that you're turning on or off, right? That's insane. Nobody does that. So instead, what we do we take a parameter called options. We let the person just give us a block, essentially. Then it's our responsibility to take a look through that block and see what we want. If I'm trying to compare something and I know it has to have a value in order for my slider to work, because that's totally a thing. My slider, for example, has to have a speed. So in this particular BX slider, the default speed is 500. That's because when they're going through and looking at your options, they're going options, speed equals options, speed, or 500. So they're either taking the person's past options that they passed through, or they're defaulting to 500 because speed is going to show up as undefined or some other issue. Why don't we return that? So, you know what? We'll just console log that. Like so. We won't pass anything into options. We'll just leave it as an empty hash. Let's go back into here. We'll refresh. Whoops. I'll leave a return statement on line 70. Doesn't like these silliness. Oh, helps if you call the function. And we're going to give it an empty hash. Actually, we can give it options. Why is it? Give me things. Let's do verboseness. Fine, let's turn on info. There it is. That's why. And as you can see, speed has been defaulted to 500. And the reason is because my user, my developer, didn't pass in the option of speed. Now, if I change that, to 7,000, notice it's changed. And the reason is because now when it does the comparison, it's been set. And so the default gets ignored. Does that make it clear? Can you now kind of see where you would use that? No? You're going to see this quite often, especially if you're working with plugin libraries in JavaScript, because this is common. It's so common to do this practice. When it becomes really cool is when you start using it in other languages, like C++ supports OR, used in that way. You can do that in C++, and it's a very rudimentary language, right? That's like the ground level for JavaScript and so many other languages. Underneath the hood, they're running to C or they're running to C++, and they support the OR operator. They support the double ampersand operator. So they are things you will see. All right, any other questions? No? Does that make it a little clearer?
I kind of like this one, but it's like more clear after you explain with an example.
Oh, okay, good.
I was wondering about the ampersand thing.
Ampersand, I honestly couldn't think of an example off the top of my head. Like I said, I've never used it, and I very rarely see it. Yeah. So if I can come up with an example, I will post it and let you know. But other than that, I don't have one off the top of my head. Does anybody else think of an example when you would use double ampersand? No. The ORs you see often, the double ampersand, not necessarily as much. All right. So, cool enough. We are done numbers. Awesome. You guys are like, I don't like the OR thing. Why'd you teach us that? It's stupid. Broke your brains. Let's do strings. And then we will move on. All right, before we do the string, let's go get that string element. You know what? Let's do this fast. Let's do strings super fast. Forget the stupid string element thing. We're going to console log everything to the string. All right, let's take a look at concatenation. Concatenation inside JavaScript, you've seen this already. Just the plus sign operator, that is our concatenator. I don't know if that's a word. It is now. Fantastic fisherman. And then we'll just console.log that out. Concat. You ever notice when you need the little things to show up, they don't show up? There it goes. Weird. We'll refresh that, and we see Bob is a fantastic fisherman because the concatenation is going through and essentially building the string and then returns the string built back to the variable concat. I think I have one too many spaces in there. So that's cool. We also have, we can concatenate other variables. So if we did, let name equal, let's go with Miranda. That seems like a good name. And then we'll say concat equals name plus loves cheese. Console.log, or just duplicate line 13. Refresh, and we get Miranda loves cheese. That's pretty normal, right? You guys have seen that in other languages as well. If you're doing concatenation in C++, it gets a little trickier. But in JavaScript, it's pretty easy. It's fairly simple. If you do it in PHP, it's simple. Most languages do it simply. So this type of thing where you take a variable and add it on, that's a very common practice, right? However, some languages give you something else called string interpolation. How many of you have heard of string interpolation? No? Oh, cool. Okay. String interpolation basically takes a string, and then using symbols inside the string, it evaluates it, and it will evaluate raw JavaScript or raw PHP or raw Ruby or whatever it is inside the string, which is awesome. In most languages, you can simply use the double quotes, and then they have like a little symbol. Like for example, if I was writing this in PHP, it would be oh, wait, did that wrong. Sorry. I can't remember. Does it have to begin with the dollar? I totally forget. I think you can also do this. That's how you do it in PHP, right? You just put the variable right in there. The unfortunate thing with PHP is you can't do stuff like and expect it to evaluate. It won't. It'll just spit out raw, parenthesis 5 plus 5, parenthesis likes cheese. That's all it will do. However, JavaScript gives us a little bit cooler stuff. Let's call this let string interpol equals. And in order to do string interpolation in JavaScript, we're going to use a character that you are not familiar with or have used likely often. It's the backtick. And you will find the backtick under your escape key. It's when you don't hit shift on tilde. You get the backtick. It does feel a little dirty, doesn't it? Yeah, I don't know why, but it does feel a little dirty. It's like, you're not a quote character. Stop pretending. But it's stupid powerful, so it's totally worth it. Like, you just kind of have to take the lump with it. Anyways, to concatenate, if we want to spit out Miranda loves cheese and put the name right inside the string, we use this structure, $, 2 curly braces, which is essentially like passing a block. This is basically what we're doing. We're passing a block. I put name inside there, and then on the outside of that, right, loves cheese. Now when you refresh, it's not going to do anything because we need to console it out. Console.log string interpol. And we get Miranda loves cheese. But we're not limited in JavaScript. That is a full-fledged block. That is a usable, workable block, which means you can pass expressions into that block, which means I can do 5 plus 5. Cool. I get 10. Yep, that's a screw you, PHP. Right? But I'm not even limited there. New date. Look at that. Instantiator an object. Right in the string. Nice. Yeah. Tuesday, September 18th. Loves cheese. That's today. We can do lots of things. You can pass an array in there and join it and concatenate it. You can do whatever you want. This is really, really handy when you're working with data and you're trying to form expressions like strings and stuff of information. It becomes very handy. Concatenation sucks. Interpolation is awesome. Interpolation gives you a lot more flexibility. In in Ruby, for example, in Rails, not Ruby specifically, but in Rails, we have a function called number to currency. So when you're building an e-commerce cart, that's really handy. And I can put it right inside my string interpolation. And it will just call it immediately, which makes things a lot simpler when you're building out massive templates of HTML and you have these wonderful string interpolation functions. String interpolation, very cool. Definitely something worth remembering. We also have escaping characters in case you don't like it, in case you're like, backticks are dirty, I don't want to touch them. That's totally fine. We can also do, let's escape car equals, this is, hold on, we'll write it out, a wrinkle in time, Sean's favorite book. There we go. All right. A wrinkle in time should be quoted, right? We should write quotes around a wrinkle in time. But we have a problem. Single quotes is not the correct grammatical character to use. The correct grammatical character that we need is double quotes, right? So some people may be like, well, then forget it. We'll just change these out to single quotes. And all will be, oh no, it's not good. Now it's really broken. Why is it broken? Right, because of Sean's, because of the apostrophe. So we have two options to us. We can escape this apostrophe by using the backslash. That'll escape the character, which says, nope, this is not a JavaScript thing. This is a literal character. Please spit this out as a literal character. So that's what it does. It spits it out as a literal character. Or we can back that up, re-break this thing, put our quotes back around, and instead, backslash, quote, backslash, quote. And you may have to hit the delete because your IDE will try to throw in two quotes sometimes. But you can just escape the double quote characters. Escaping is important. You're going to encounter it all the time. If you don't want to escape because you hate writing those stupid characters, just remember it doesn't care. Because backtick is not a single quoted character or a double quoted character, so you can just use backticks.
That's a cheat. That's a cheat.
It feels, I have to agree, it feels so hackish. It does. It feels completely hackish. But it's been, like, that's ES5, so that's 2015, 3 years old now. So it's like, it's a part of the API.
So this backtick is only JavaScript, like no such a thing in JavaScript.
I don't know. Let's find out. Let's load up a language that isn't JavaScript. This is the wonderful world of Ruby, which makes things really nice. They give us a console to work with. Let's do this is a backtick. Please don't blow up. Nope, doesn't like it. Treats them as the end of EOF, which is end of files. That's a weird thing. We might talk about EOF at some point. Not likely. It's pretty advanced.
So that's a Ruby?
That's Ruby, yeah. Similar to JavaScript in kind of syntax, except for no semicolons. You don't use semicolons in Ruby. But yeah, so it doesn't support backtick. So I'm not sure. It might come from something else like Python or something like that, or Perl or something older, but I have no idea. Yeah. Cool. We also have tons of string methods, but here's the very awesome thing about string methods. A string in JavaScript under the hood is a character array, which means it abides by the same methods that arrays abide by. So my string.length will give me out the number of characters in my string. My array.length will give me the number of elements in my array. They're the same. Almost everything is like that except for replace. Replace is one that is not, and changing text. So let's take a look at the methods that are not a part of an array. So we'll do let. Actually, you know what? We'll just do this inline. Console.log. This is a string. And then, right at the end of the quote character, we're going to add a dot. And we're going to call to uppercase, which is a function. And if I refresh, now we're yelling. This is a string. If we want to make it all lowercase letters, to lower, I can't remember if it's to lowercase like that. I always forget. Yeah, this is a string. I have to look up the syntax sometimes. I work in like 8 different languages and I forget syntax. In Ruby, or sorry, in Rails, it's to upper and to lower. And then, but they also have title case and capitalize, which JavaScript doesn't have, which kind of sucks. So if you want to titleize your JavaScript string, you'll have to write your own method for it or use a library. A good library that a lot of people like is underscore. You use that. We can also replace text. So console.log. Actually, hold on. Let's create a variable. We're getting really lazy. Hello. Hello, world. Yep. Everybody loves hello, world. Though I hear the grief in your voice. Console.log. We'll just output hello. And then we'll do console.log hello.replace hello with, sorry, not hello, world with Dave. Hello, Dave. Anybody 2001 Space Odyssey? Yeah. Sometimes people get my quotes. Not always. I mean, that's a pretty obscure one. Unless I beat people with like a bone or something. Oh.
I tried to tell someone something I was building. I was like, like Speaker's Corner. And they were like, oh.
You know what Speaker's Corner is? I was an angry 16-year-old alternative kid when I watched Speaker's Corner. Oh. No way. Lucky you. Yeah.
Hello has already been declared.
Your what has?
Like, it's already been declared. Hello has already been declared.
Maybe you declared a variable further up called hello, and now you're trying to declare it again. So that's what that means. If you get an error saying hello has already been declared, it's saying, hey, you've already created a variable called this, and now you're trying to create it again, and I'm not going to let you. You need to either rename that one or rename this one. So just call it something else.
There's nothing like that.
Call it hey. I'll take a look in a second. All right, so we have just powered through a lot more than an hour's worth of stuff. It took 3 hours, and we ran out of time last time. So we just powered through a ton of stuff. That is it for that part. We're going to do arrays next. Yeah, we're going to do arrays because arrays are a lot more complex than variables, strings, and numbers, which you guys are used to because you play with these things all the time. We're going to do arrays next, but before we do that, I think we'll take a well-deserved 15-minute break, get coffee, get whatever you need, and then come back. You love arrays? We'll start up again. We'll just take it a little slow. Some people are still coming back. I don't know if Tim Hortons was like a busy lineup or not. If you go to the weekly lessons, though, weekly learning, you will see week 3 arrays. Go ahead and click on that. And in there, there's a whole whack of different things. There's a review for strings, and numbers and variables. As we learned last week, though, if everybody hits that link at the same time, Heroku basically shits the bed. So stagger, go to it when you have leisure or whatever. Just go to it and fill it out. Kind of helps me kind of see where you guys are at and see where the other group is at, so I know how to progress forward. Because as Scott says, this is my first kick at the can with the JavaScript class, the client-side JavaScript class. And while I do have course material from other instructors, I kind of prefer to build my own. And that being said, I want to make sure that I'm keeping pace with you guys and not going too fast. All right, so if you want to do me a favor, download the arrays starter files. Save those wherever you're going to run them from. Decompress it, uncompress it. I don't know what the word is. Unzip. Sounds wrong though. Unzip my array. I mean, it sounds wrong now.
Now they're all laughing about it.
All right, let's open up that inside our IDE. I had some fun with this one a little bit with the styling. Not as much fun as I had with the Tic-Tac-Toe game. I had a lot more fun with the Tic-Tac-Toe game. All right. Okay, we can close this off. I have created a method to do this a little better, just because outputting to the console is kind of annoying all the time. Let's see, open file, navigate to wherever that is, no, here, and open up index.html. In the end, we got there. All right. I'm just going to open up the console just to catch any errors. I did error check this, but you never know. It comes up sometimes. And first, we should just open up the index.html. Make sure we haven't missed anything. Looks like step one is add the external JavaScript file, but it's already added. Or is it? Yes, it is. It's already added, so we don't need to add it. Let's just make sure we have our CSS file. Looks like we're good. We have styles.css. So we're ready to abandon that and open up the arrays.js file. Arrays, right? Every programming language, probably one of the most powerful things, one of the best things to learn. Arrays allow us to basically contain data, right, inside a structure, usually a list of data, and most times it's a list of like-minded data, right? Doesn't really make sense. I think I showed you guys on the first day, we took Bob, 39, and True, right? Those things don't really relate to each other. It doesn't really make sense to create an array of them. Might make sense to create a nested array, though, and have that as one element, and then have another element like Nancy, 24, and false, right? As long as it's like-minded data and it's contextually the same, it doesn't really matter. In JavaScript, though, there's a time to use an array and there's a time to use an object, right? It just depends on what you're trying to do. Arrays are generally for list items, things that you really want to keep a list of. And that's what we're going to do as an example today. The first thing I want to do is actually go out and grab the arrays element that is sitting on my page. I have an arrays element. I have an element with the ID arrays, right? So let's store that in a variable. We'll call it let section arrays equals document dot query selector hashtag arrays. Hashtag is the CSS symbol. It tells the selector, I want an ID, and then the next characters that follow it are the label on the ID. I love query selector. It's an easy thing to teach, as opposed to get element by ID, or get element by class name, or get element by CSS selector. Those are all really confusing. This kind of bundles it all together into one selection type. Very, very handy. All right, we're going to create an array of heroes. You're welcome to create an array of whatever you want, but I'm going to create an array of heroes, and I'm going to call it superhero teams. Superhero teams equals And I'm going to go with the Avengers, the Fantastic Four, and something a little bit more obscure, like the X-Force.
Wait a second. I ask you a question.
Yeah, go for it.
X-Force is it's
Marvel.
X-Force.
Yeah, Deadpool is part of
I
X-Force.
was
Cable comes from X-Force.
So it's not X-Force.
X-Force.
Seems a little derivative.
All right,
I thought it was like X-Men or something.
it is noted.
It is. That's the whole joke, man.
Yeah. Let's console.log that out. Superhero teams. I'm going to form my own superhero team. And then we'll refresh. Sure enough, we have our array. Now, something very cool. I'm not sure if you've noticed this inside your console. I think I pointed this out before. When you output an object or an array, you usually get this little triangle beside it. And the triangle is really cool because the triangle, when you click on it, it shows you all the things that are a part of your array. Ready for a brain break? An array is an object.
No.
It has, I love your enthusiasm. It has methods and functions attached to it that are available to you. It is a primitive. It is a data primitive. However, when you output it like this, when you call it and you output it, JavaScript wraps the array into an object and then outputs the object. And you now have access to all of its methods and functions that are available to it. And if you want to look more at this, anytime you see things like this, like string, and it's got functions and stuff, it's done the same thing. It's wrapped that string in basically an object. And you can access these through prototype. So there's a thing called array.prototype, and that is the actual class name. And you can go take a look at that on MDN anytime you want. Just suffice it to say that your array currently is an object, not to confuse you. Let's just treat it like an array. The only reason why I'm pointing it out is because people get confused and they don't know where all these methods are. Like, where's array.length coming from? Where's array., I don't know, index of coming from? Where are you getting these from? And what's cool is in your console, you can actually find references to all these functions by just clicking the little arrow beside proto. And you can see all of the functions that are available on that array. And there's a huge laundry list of them. Like if I want length, there's length right there. If I want pop or push, they're there. Reduce is there. Reverse. So you can actually take a quick glance and see if any of them are labeled to what you're looking for. Say you want to reduce your array. You can go through that list. Oh, yeah, they have a reduce function. And then where would you go if you wanted to know how it worked? MDN. That's the best place to go. Yeah, you could do that as well. You can click on it. And I believe you can actually look at the function itself. There is a way to actually look at the function definition, but that would be so hard. Just go to MDN. So much easier than looking at the function definition. But anyways, that's a handy spot. So same as strings, same as objects, same as anything. If it's been wrapped by an object and you want to know what methods and properties are available to it, spin it out to the console, and it's much easier to take a look at it. If you're using Chrome, sometimes it takes elements and just spits out the string version of that, right? It just immediately casts to string, and you get the string version. If you want this version, where it has the arrow beside it, instead of calling console.log, you call console.dir, D-I-R, and spit out whatever it is, and you'll get the prototype. You get back to the prototype part of it. All right, cool. Anyways, that was a little bit of a segue. Let's turn our array into a multi-dimensional array. We're not turning nothing into a multi-dimensional array. We're creating a new one. Let team members equals. There's a few different ways you can write this. The cool thing is in JavaScript, we can actually do things on multiple lines. So let's do that. Multi-dimensional array, array of arrays, right? That's what a multi-dimensional array is. Nested arrays, some people call them nested arrays. All right, in the Avengers, we have the Incredible Hulk. Actually, let's do one of the more obscure Hulks. Omega Hulk. Omega Hulk is when the Hulk hulks. You ever seen that? Imagine the Hulk getting so mad he hulks out. That's Omega Hulk. What's that?
Just gonna stick with just
That's fine. You can stick with just, then you might as well say Cap instead of Captain America.
probably what I'm gonna
Ultimate
do.
Spider-Man.
Thank you for the idea.
Oh, yeah, let's go with that. Ultimate Spider-Man.
That's when Doc takes over and then we're
All right, we have Ultimate Spider-Man. Now we're ready to move on to our next array, right? And Fantastic Four has had other members in the past, but we'll just list the base. Invisible Woman, The Thing, Human Torch, and Mr. Fantastic. Sounds more like a porn name than a superhero name. And then for X-Force, this is like the base team. Warpath, Cable, and Domino. And now we can console.log that out. Team members. And then we can go ahead and refresh. And now you will see you have a nested array of arrays. And when you first look at it, it just says this 3 wrapped in parentheses, and then array with 3, array 4, array 3. What are these numbers? They have significance. Yeah, it's the size. It's the number of elements inside these arrays. Okay? So we have an array with 3 elements, and then each one of these elements contains 3 elements, 4 elements, and 3 elements inside them. And if you want to view inside them, just click the down arrow, and you can see the 3 elements. And then if you click another down arrow, you can see the elements with inside there. And then you can go see the prototype for it as well and all the different information about it. Now, just so incidentally, when you're going through this list, you might be curious, well, what's a function and what is a property? How do I know the difference? Just on observation, how do you think I know the difference between a function and a property in this list? Here. What do you think is my teller? Yes, that's literally it, F. The little f means that this is a method. It's a function. And if there's no f, like beside length, it means it's a property. Okay? You guys took object-oriented programming, right? Difference between a method and a property. Property is data. Usually methods are actions. They're actionables, right? May not have been explained that exact same way, but I always kind of treat it like properties are nouns and methods are verbs. There's things that you do. Properties are more, or they can be adjectives or descriptive. Yeah. All right, cool. End of grammar. Step 3. Yeah, we did that. Oh, so now if I want to access a specific element in my array, and JavaScript is 0 indexed. Hopefully you understand what I mean by that. JavaScript is 0 indexed. Not many things start at 1. I think there's one language that starts at 1, and it's like Perl or Python, or it's one of those guys. It's a weird one. But anyways, it's 0 indexed. So if I want to access the first element of my array, so we'll do superhero teams. If I want to access the first element in my array, I add square brackets and I call 0. And that's the Avengers. If I want to access the second element of my array, I would change that 0 to 1. And that returns back Fantastic Four. If I want to access an element in a multiple, or in a multi-dimension, in a nested array, let's just say that. In a nested array, I do console.log team members. I select the element that I want to first target, the parent element. So we'll say 1. And then the element of the second array, so I'll say 3. And I wrap those in square brackets. And I have Mr. Fantastic. A lot of languages work like that. I don't program in Java. Is that basically the same syntax as Java? Yeah, I thought so. A lot of languages work like that. C++ works like that. I can't really think of any that don't use the square brackets in that way.
C# uses like 1 comma.
Really? To do like nested?
Yes.
That is, yeah, that's a bit different. All right, if I want to access the last element in an array, it gets a little trickier. Let's access the last element of the superhero teams. What is very cool is that inside these square brackets, you can think of these square brackets like they were a block, which means you can actually add code in there that will be parsed and return back, which is cool because then you can have dynamically searchable arrays and stuff like that just by adding code inside that. And if I want to get the last element in the array, the way I do it is in the square brackets I call superhero teams, so the name again, dot length. And I can't stop there because dot length returns back the number of elements, but arrays are 0 indexed. So what do I need to do?
Plus 1.
Whoa, that's 2 very different answers. Adding 1 or are we minusing 1?
Minus 1.
-1, yeah. And if I refresh, we get X-Force, which is the last team in the array. If we were to add 1, incidentally, this is the thing to note in JavaScript. JavaScript is the silent killer. It is the thing that will screw up your code and not tell you why. Just doesn't. Any of you that get into OpenGL are going to find out your graphics card is the silent killer. That is one-way communication, and that's all there is. Same with JavaScript. You don't know unless it catastrophically blows up. You won't know. So if I was to add 1 to this, that array element doesn't exist. And if I call refresh, I get a very quiet undefined. Right? No warning, no error throwing, nothing. Just undefined. If I do this in C++, it explodes and throws a temper tantrum. If I do this in most languages, it explodes and throws a massive temper tantrum. JavaScript's like, it's all good. It's just not there. Right? Super helpful. All right, JavaScript, the uber chill language. Console.log, let's get the array length. And I kind of already alluded to how we get the length of the array. We literally just call the array and call the property on it dot length. And we can do it for both of our arrays, console.log, team members dot length. How many elements, what's this number going to equal? Team members dot length. What is that going to return? It'll return, sorry?
2.
Who says 3? Okay. Who says 3 plus 3 is 6 plus 4 is 10? Who says 10? Because there's technically 10 elements if you count all the ones in the nesteds. Yeah, some of you? We're going to get 3 because dot length isn't recursive. You guys know what that means? Recursive? For those of you that don't know what recursive means, it means it only reads the surface layer of the scope, right? So right now we have 3 elements in that surface layer. And it's going, yeah, you've got 3. It doesn't give a damn about the ones contained inside each one of those because it's not recursive. It's not going to be like, oh, wait, you've got children. Okay, well, I'm going to dig in there and go count all the children up. And then I'll come back out and I'll go to this guy. Oh, no, you've got children too. Now I'm going to dig in and grab all those children and count them up too. It doesn't do that. It only counts the top level of whatever it is that you want to count. So if I want to count the team members at the next level, I have to provide it an element. right? And then if I want to count the next one, I got to provide that element. And the next one, I have to provide that element. And now when I refresh, I can get back all the element lengths. That being said, you can do recursive functions and run your own recursion and do these counts. But there's nothing built into JavaScript that just does it automatically. If you want to do a deep, it's called like a deep, I don't know what they call it. Like in Ruby, it's called a deep merge. If you want to do a deep merge, you have to include a library to do that, or do your own function. And we do have a couple of functions available to us in arrays that help with things like that. But before we do that, let's talk about why we actually use the array length property. One is to do iterations, right? We're going to talk more about iterations next week. But let's build a simple for loop, right? We all know what for loops are. It's the one loop that seems to have the same syntax in every language, except Ruby. Ruby doesn't use it. It's like, I'm too cool for for loops. Use .each, loser. Console.log. Here we go. There we go. That's a typical for loop. Basically what I'm doing is I instantiate a variable and assign the value of 0 to it, right? Then I grab the length of superhero teams and I run a comparison against it. Are you less than superhero teams? If you're not, then increment I. We're so used to doing this. I don't have to do plus plus I. This just works, right? We're just used to doing I plus plus. I run I plus plus, and then I can console.log out superhero teams I, right? Which basically says take the value of I, and I'm going to use it as an index. And I'm going to pass that to the array and spit it out. That's dynamically spitting out our array, right? And if I refresh over here, if I can find my mouse, you can see I've got all my superhero teams, right? That's slow. Not slow benchmark-wise, but slow to write, right? It's not very clean. It's not as clean as, say, this. Right? For each is a little easier. The only problem with for each is inside these wonderful brackets, we get the legendary callback, right? The anonymous function that we're going to pass to JavaScript and let it fire off on each element. So we have to call function. Inside function, we have to provide it something, so we're going to give it the element. It's just a variable name. You can call it Bob. You can call it whatever you want. Sorry, only dirty words came to mind. Decided against it. And then we're going to do console.log L. And if we refresh over here, we get the same thing, right? But the problem was a lot of people were reading this over the last few years because for each came, it was before ES 2015. It came back a while ago. People were like, dude, this looks like jQuery. Why are we writing jQuery to iterate, right? And people were like, it's for each, man. It's cool. It's awesome. You can give it a callback function. It's totally cool. It's wicked. It's wicked cool. And they're like, no. We need something much simpler than this. Not anything so complex. So as of ES 2015, we now have this one. And this one I love. This is so beautiful. Let superhero, actually let's shrink that up. Team of superhero teams. See how pretty that is? Console.log team. So nice. I'm a Ruby developer, right? And how many of you actually coded in Ruby before? Oh, when you code in Ruby, you never want to go back. Because it's elegant. It's an elegant language in the fact that it's readable. You don't need to litter. In fact, if you're littering your code with comments, you're a shitty Ruby programmer. Your Ruby should read. They have unless. You know how you have if, right? If this, then that. Ruby has unless, which is the opposite to if, just to maintain readability, right? It's fantastic. I love Ruby. This feels Ruby-esque. Definitely feels Ruby-esque. For let team, it even reads like Shakespeare. For let team of superhero teams. Right? It just feels so perfect. I love it. Maybe a little too much passion over the for statement, but whatever. Out of these three, just out of curiosity, out of these three, let's just take a vote. How many people prefer the normal, concrete, your baby boomer parent for condition? This one.
Love it.
Yeah, all right, cool. How many like the jQuery way? How many love this elegance? Yeah, that's what I thought. And what's really cool is when we get into objects, which we will later on. So let's just create a quick object. Let's do name, Sean, age 39. When we get into that, that syntax carries over to objects, and we can actually iterate through our object by doing this. For let o, only we don't use the word of, we use in, obj, console.log, o.name, o.age. I think that's how that works. No, I've got that wrong. I've done something goofy here. Hold on, let's just console.log o, because I can't remember how that works. Oh, right, sorry. It iterates through our keys and spits out the values. That's what's happening. So these are our keys, and these are our values. So it's going through and spitting out our values. All right. I wasn't going to teach iterations quite yet, but it's important when we build Tic-Tac-Toe. We need iterations. Otherwise, could you imagine the length of code if we didn't have iterations? My God, every time we want to check a win condition, it'd be terrible. So we need iterations. All right, now if I want to iterate through team members, for example, and pair up their superhero team, right? It's a little bit more complex. We'll use a standard for loop for this. For let j equals 0. If j is less than team members. No, wait, I'm missing one of the opening parts. Nope, my apologies. Let j should have been the telltale for me. Let I equals 0. If I is less than superhero teams, dot length, I plus plus. We've done this already, right? Okay. I'm just going to close out that. So there's our opener. I just deleted the curly brace that your IDE automatically creates for you as the closing curly brace. Just delete it. We'll add it again towards the bottom. Let's create an element on the page. And I don't think we've done this yet. I don't think we've actually created an element on our DOM. We're going to add a new DOM element. We're actually going to create a chunk of HTML and put it onto the page. And the way we do that is we're going to create a variable first so we can keep track of it. I'm going to call it team name li equals document.create element. And then this is the coolest function in the world. All I have to do is give it the name of the element that I want to create. I want to create an li, so I just type in li. There we go. Incidentally, in case you didn't know, li stands for list item. That's what it means. So that's cool. I've created this li. I'm just going to expand this a little bit so it's a little bit more legible. And shrink up that guy. There we go. Awesome. Step 4D.2. Set the text of the li to be the superhero name. Does anybody remember the method we used to set text on an element? Set text? No. It does have the word text in it. Let's go team name li dot, I'll start to type it out, TEXTCON. Oh, fuck it. Superhero teams. All right. There we go. What am I doing? What is this doing? I'm calling .text content, right? First of all, this is the li element that we just created. This is our list item. This is the text that we want to put in here. This works two ways. If I call team name.li text content and just output that, it will output whatever the value of text content is at that time. If I say equals, I'm now assigning text to it. I'm now shoving text into that li. Superhero teams, I. What is this? What is this doing? Why do I have an arbitrary I in there? Where's that I coming from? From the loop, exactly. I'm iterating through all the superhero teams, and I want to actually spit them out. Only I'm not actually spitting them out. I'm adding their name to the team name li text content. Don't worry. We're going to close off this little console window because it's going to spit out something very cool. Actually, I'm building that up way too much. Lower your expectations. All right. Next, append the li to the team ul element. Well, we can only do that if we have it. So I forgot to create it. On line 84, let team ul equals document.create element. We've done this once already. What's the name of the tag I'm creating? Does anybody know? ul. There we go. Now we can jump back to line 94, where we have step 4D.3. Append the li to the team ul element. All right. So team name li dot append, or append child if you so choose. Totally up to you. Why don't we use append child just because I like how it reads. Append child, team name li. Nope, did that wrong. So at the beginning, it's team ul. We don't append children to children. It doesn't work. It creates a loop, a nasty loop. So this essentially takes the li that we just created, that we stored our superhero team in it, and it now adds that li to our ul. We're building a list, right? Right now we started with the superhero team names. So that's cool. Now we want to add the members of each of the team. So we're going to do let member ul equal document dot create element. I'm assuming you know exactly what I'm creating here, ul, right? And we're essentially going to create basically a nested list, right? Not basically, it is. It is a nested list. First thing we're going to need on line 103 after step 4E.1, create a for loop to iterate through the team members. All right, so we're going to do for let j equal 0. If j is less than team members, I, dot length, then j plus plus. Remember I said when we call dot length, it's not recursive, right? It's not going to go through the array and tell us how many elements there are. Because of that, we have to basically create a loop inside a loop in order to iterate through and grab back all those elements. It wasn't accidental that we created 3 nested arrays because we had 3 teams, right? Makes sense. I want to iterate through all 3 teams and spit out all 3 team members. So we need to create a nested loop. The first loop iterates through the superhero teams, 0, 1, and 2 index, right? Now we can use those 0, 1, and 2 index and feed that into our team members to grab back the nested array that we want. Create a new li element for the member name. All right, so let member stop things. Let member name li equal document dot create element li. That's awesome. Oh, we need to work quicker. Step 4E3. Set the text of the li to be the member name. Well, we already know how to do that. Member name li dot text content, right, equals team members. And what are my indexes? What's the first index? I. And what's the second index? J. There you go. That's now grabbing each team member from each of the things. Step 4E.4, append the element to the member UL. Yeah, the member UL element. That's a mouthful. Member UL dot append member name li. So now that's appended.
Just regular append or append?
Either or. Let's do append child. Why not? You can do either or. Doesn't make a difference. I think one's a newer syntax. And then close that for loop with a curly brace. Yeah. So we've closed one of them. We still have one left open because we're not quite done yet. All right. Anybody not ready to move on? Yeah, I'll give you a second.
Why did we define the team name UL? Like in which step?
We did it up here on line 84. Under 4C.1. I'll leave that open for a moment. Yeah, no worries. I'll let you write it. I'm really excited about Tic-Tac-Toe, so I really want to get to it. So I think we'll spit this out and then we'll move to Tic-Tac-Toe because all the methods we're going to talk about are in the Tic-Tac-Toe game. I mean, who doesn't like to play Tic-Tac-Toe? Tic-Tac-Toe is fun. Are we good?
Yeah.
Awesome. Let's move to step 4F. Create a new li to store the member UL when dealing with nested lists. They must be wrapped in an li tag. Wow, it helps if you use punctuation. So nested lists, when you have a list element in HTML, you know how list elements are defined by the UL or OL tags, right? And then you have your list items. If you want to nest a list inside a list, so like I have a bullet point and then I have bullets for that bullet point, you have to actually include an li first, and then you can put the UL inside of it. You can't just jut the UL wherever you want, or it's technically not valid HTML. So we have to actually create a team member li. So we're going to call it let team member li equal document dot create element li. And then we're going to append child, or append, totally up to you, the member UL to it. And then, we're almost done, team UL dot append child team member li. And now we're appending the li tag to that. And then very last, but not least, the closing curly brace. Now I've added some fancy styling. Hopefully everything works. Oh wait, I'm not quite yet done. We're almost done. I forgot. Step 4G. Append the team UL to our section element. Well, obviously, because we want to be able to see it on the page. So I need 4G. It's called section arrays, and we defined it at the top of the page. At least I hope we did. Yep, we did. There we go. Dot append child team UL. And if it works, that's what you should get. Hopefully that's what you get. You might not get the stars. I don't know if you will. You should. Yep. Tell me when to stop.
Yeah, you're going too far.
Can you upload it on GitHub?
It's already there. It's already there. I always upload the lessons Like I make them on Saturday and I upload them Saturday evening, generally. Even part of week 4 is there. Don't look at it, shit. Don't look at it. Wait till I finish.
Can you explain these steps in a brief after we're done? Like just
Yeah, there's comments in there that explain all of them, and then there's big note blocks that tell you exactly what's going on.
Hey.
I'm sorry, it's him. It's his fault.
Now you've gone too far.
What?
Like legit, you've gone too far. Thank you.
Right there? Okay. I'm just so excited. I really want to get to Tic-Tac-Toe. How many people have this on their screen? A couple of you? With the stars and stuff? You got the stars. Do you have this font? Yeah. Okay, good. I wasn't sure if the CDNs would work because we're not technically running a server. We're just running this off a file, so sometimes the CDNs won't actually work. So it's cool that the CDNs work. Do you need me to scroll down or up or... No? Are we good? Yeah?
It says you cannot read the property
Alright, so that means that section arrays isn't spelled correctly. I'll go all the way to the very top where we actually find it. And it looks like it's spelled right. Oh no, you have a capital A.
Nothing.
No worries.
I have nothing.
Do you have errors?
so much for that.
Do you have errors?
Yes.
You have a syntax error. You have an unexpected token of a brace. There you go. This is a new error. Reference error, team UL is not defined. Yeah.
Oh, is it because we didn't team name?
Yes, I think so. I don't know. No. Yeah, sorry, you're right. Oh, I thought it was team UL. Incidentally, if you're looking for this code, just to make things, sorry about making things go quicker, but I just want to get a little faster. 1073. If you go to GCS, so if you go to github.com, GCS McKinnon /comp1073, this link is also under resources. And if you go to week 2, nope, sorry, not week 2, week 3, you'll see arrays. And if you go to array.js, all the code that we just did is sitting up there right now. And extra code that we didn't do, which will help you. There's about 254 lines of code there with comments and active notes and everything to help you walk. So whenever you get undefined, basically what it's saying is this variable you're asking me to access doesn't
Yes, I get errors always.
So it's
It's
very
just telling, it's
limited.
just a warning telling you that it's available.
And then keep in mind that spelling errors in computers are very good.
That won't stop it.
Capital A is
Stop
not the
it.
same as lowercase. It's very good. Right?
Or right
So you just have to make sure that that's not the case. So if you go back to the error, it actually tells you what line it's on as well. It says on 100.
I'm not following you.
So this is saying seeing numbers, it's saying it's not. It's also possible that every person is trying to access. Yeah, so it's going through and it's trying to do 0, 1, 2. If one of those is missing, then we'll be fine. You're always welcome to package that up and send it to me via email, and then I'll take a look at it and tell you about it. All right? Just so we can move on, if you have an error in your code and you can't figure it out, one hint is if it says undefined, It is very much a variable naming problem. I have people do this to me all the time. They're like, dude, I did everything perfect. I did it exactly the way you said it. It's not me, it's the browser. I will tell you 99.9% of the time it is you. It is very, very rarely the browser. It is possible the browser can cache your JavaScript. If that happens, you can do a hard refresh by doing Command-Shift-R. But it is 99.9% of the time, not the browser. That being said, if you still can't figure out where your syntax error is or what the problem is, email it to me with your name, what class you're in, so make sure you say it's Tuesday, and a zip of your file, okay? And what I'll do is I'll review it, figure out what went wrong, and then I'll send you a message and tell you exactly where the error is and how to fix it, and then how to recognize it the next time, okay? Kind of a way for me to give back to you because I would like to move forward. It would be nice to be able to do the tic-tac-toe thing where I feel like it will be easier to grasp arrays when you see it in a real-world example. All right? So in order to do that, we will need to go to weekly learning, week 3 arrays. I'll close this one off. Go to where it says Tic-Tac-Toe starter files. Click on it. You should be very used to this whole process now. Save it to wherever it needs to be saved. Show in the Finder. Open up the folder inside your IDE. And we might have to make one small change in our CSS file. I do promise we're not teaching styling in this. Styling is a you thing, not a me thing. Do you guys get, do you have an HTML class this semester as well, advanced HTML? No? Yeah, they teach you like more advanced techniques in CSS and like about the picture element and template elements and stuff like that.
More the web programmers.
And then if it's Scott, he also gets you to install WordPress, and you guys spend some time in that really crappy framework. Okay. That's our tic-tac-toe game. The background I stole, to be full honest. The rest of it is ours. Now, it is bizarre that I'm not actually getting all of the things I need, but we'll figure that out in a second. The first thing we're going to need to do is patch up the actual main.js file. We need to attach it to our tic-tac-toe. So if you open up the index file, scroll down to where it shows the script tags down here. In order to attach main.js, what attribute do I need to add to the script tag? Yeah, the source. There we go. Not sure why I'm not actually getting my view here. I'm not even getting warnings. Where's my styling? It's probably something silly. Oh, I see why. All right, I want to build out our actual board so that we have our board. Tic-tac-toe, very easy to build out that board, right? How many cells am I going to need for that tic-tac-toe board? 9, right? So what we're going to do is we're actually going to create a row element and then a cell line as well. So I'll show you what that looks like. In here, we're going to do div class row. And then inside the div class row, we're going to create div class cell as an empty div. And I beg you to copy and paste. Do not type this out 9 times. Okay? We're going to take that line, the cell line, and duplicate it so that we have 3 cells inside that row. Then we're going to take from where we begin the div to where we close the div, we're going to copy it, add some space between us and the other one, and paste it twice. So you'll have 3 rows and 3 cells in each one, 9 cells altogether. Okay? Now you see this very random reset game button that's just floating up in the middle of nowhere? We're going to make that not float in the middle of nowhere. So under the div, under step 3, where it says add the missing IDs, we're going to add an ID called actions. And under button, we're going to add an ID called reset. And that will allow us to be able to hook on to that very easily. Doesn't matter if we add any more buttons on the page. We can grasp onto that very simply with JavaScript by just using the document query selector to access it. All right. Anybody need me to wait for a second? No? Okay, we have one more ID to add. Up here on section, we're going to add ID equals game board. And that should complete it. And if you go to your browser and refresh, you should get a nice 3-dimensional board, well, perspective board with reset. Yeah, man. You're having a flux box issue.
Time as well.
Your kids are close this arm. No, your kids are yeah, you need to add fuzzy div text to all the cells. And then close your row tab. Who said they have a smushed board? Yeah, there's no scroll bar. Yeah, we have to do a change to fix that. You look fine. You're all fine. Yep. I'll show you how to get the scroll bar back. You're probably like, where's my scroll bar? I don't have a scroll bar. This is one of those scenarios where the designer messed up. You know, me being the designer. I was trying to go for a nice stylized, like this type of look where it looks more like a video game, so I added overflow hidden on line 19 of your CSS file. You can either comment it out or just delete it altogether. Refresh, and your scroll bars are back. Okay? You have to admit it looks ugly, though. Takes away from the aesthetic, but whatever. Maybe I'll show you how to hide scroll bars so that they're still usable, but they're not there. Whatever. Yeah, line 19 of your CSS file, either delete it or comment it out. Okay? And that's it. That's it for index.html and styles. But you'll notice this thing is not clickable, right? We have a nice hover effect. We have a reset game button. We can click it all day long, but nothing does anything. Let's open up main.js. And we'll go through this. Step 1, select and store the H1 game board reset and message into variables. So 4 elements inside our document that we're going to store into variables. And we're doing this so we have access to them so that we can interact and do different things. We're storing the H1 so we can send messages back to let them know which player is next. We're storing the game board so that we have actual access to the different cells on the game board. We're storing the reset button so that when they click the reset button, it will actually reset the game. And then we are storing a message element where we can pass back different types of messages that we want to pass back. So all of these basically look the same. So let H1 equal document dot query selector H1. Okay. The next one is let game board equal document dot query selector. And this one is an ID, so we need the hashtag game board. Then we have the reset button. Let reset equal document.querySelector hashtag reset. And then the message equals document.querySelector hashtag message. Now, we've been using Query Selector up to this point. The cool thing about Query Selector versus any of the other ones that existed in the past, like getElementById would return back the element, but if there was more than one element on the page with the same ID, it would blow up. So you had to be careful about things like that. Or it would return back an array of those elements, depending on what the selector was. Query Selector only returns back one, and it only returns back the first instance. So if you had two elements on the page that were in H1, it will return back the first one it finds. Okay? If you have more than one element on the page, like in our instance, all those cells, and we want to pull them all back, we have to actually use a different method called Query Selector All. And Query Selector All will return back an array of those selected elements. So we'll go out, find all of them, and everyone it finds back, it returns it back as an array of elements. So we're going to use that. We're going to call let cells equal document.querySelector all. And each cell has a class because if you want good HTML, you don't use an ID tag more than once. It's an identifier. It's meant to be unique, right? Don't use it more than once. So instead, if you need to use an identifier that's, more than once, some way to access something, you use a class name. And the class we're going to use is called .cell. And that allows us to access all the elements on the page that currently contain the cell class, which is all 9 of those cells. Can I scroll up, or does anybody need me to stay? No? Okay, I'm going to scroll up just to that step. All right. Let players, we're just going to create a variable. It's going to contain an array. It's going to have 2 values in it. I mean, you could create more than 2 values if you wanted to create a really crazy tic-tac-toe game. First value will be player 1. The second one will be player 2, and they're just strings. And I have to slap myself and tell myself to slow down because when I first built this, I was building it with objects. And then I realized we haven't had that conversation yet, so maybe we should slow down. So yes, if you're recognizing this and saying, hey, we could do this a lot easier with objects, and you understand that concept, you go for it, because the whole point is to challenge yourself, right? Don't follow along if you already know how to do it in a different way to learn something new, right? Wow, that sounds like a good rhyme. I should write that down and market that. All right, we're going to do the player pieces. Player piece. And it's an array that contains an X and an O. And hopefully your fonts are working, because this X and O are very well chosen fonts. They look nice, they work perfectly. You'll know if the fonts are working because your Tic-Tac-Toe will look like mine does. We need to create a variable to hold the current player's state, right? Because we need to know which player we're currently working with. So we need a way to keep state. So what we're going to do is we're going to create a variable called current player. And we're going to just make it equal to the index that we're working with. So 0. Player 1 is index 0, right? Player 2 is index 1. Just very simple way to keep track. Now, for you math geniuses out there, make fun of me all you want. You guys understand magic square math? You go nuts and write magic square math. I don't understand magic square math. I tried to learn it. I couldn't figure it out. So instead, we get an array of arrays with win conditions. So we're going to do let win conditions equals, and it's a nested array. It's going to contain every plausible win condition there is. And there's not as many as you think there would be, right? Let's think of the first one. What's the first possible win condition if we were reading left to right? Right. So what index numbers are those?
0.
2. What about the next win condition? Should be easy. 3, 4, and 5. And then the last would be 6, 7, and 8. All right, let's go up and down. 0. I'll help you out. 3, 6. I think it'll just be faster. 1, 4, and 7. 2, 5, and 8. I mean, you could really screw with people if you wanted to like mix these up. 0, 4, and 8. 2, 4, and 6. So the last two are the diagonals, right? 0, 4, and 8 go in the diagonal way, right? 0, 4, 8. 2, 4, and 6 is in the diagonal. And I don't care about the reverse because that's irrelevant, right? As long as I get one direction, I'm totally fine. We don't need to duplicate these and then reverse everything. There's no reason to. Now there is math, and you can look at the Wikipedia article, it's huge, on how to do this with math. But in all honesty, there's like 35 lines that you need to write in order to get it to work. I think this is quicker. And I bet you if you benchmark mine against that, this would still be quicker to just check the win conditions. All right, we are ready for game functions. Can I scroll up a little bit? I'm going to. Speak now.
Too bad.
Too bad. All right, step 3. Create a function to kill the game to stop any further interactions. So once our user is done, the game is won, there's nothing else to occur, we need to stop the game. We need to stop the world. We don't want them to be able to click other elements moving on through the game. So we're going to create a function to basically kill the game. We need to do this quickly because Jessica's going to be here very soon. So function, spell function correctly, kill game. Open that up. I now have an arbitrary curly brace. Oh, my IDE was so nice and put the closing curly brace already at the bottom for me. I love it when it works correctly. We're going to iterate through all the cells, and we're going to use that handy for loop we learned. So cells dot for each with a capital E. That takes a callback function. We pass it an argument or a parameter for it to fill. Right? So it's going to iterate through these cells. Each cell is going to get passed into this function and now be available to us within the function body. take the curly brace and the parentheses, the closing curly brace and the closing parenthesis, cut those, and add them just underneath down here, and add a semicolon. So line 49. You need to move them to line 49. And that'll close that off. I should have did the for loop instead of this thing. Okay, there's a few things we have to do. One, we're going to add an event listener to these so that when people click on them, it toggles the piece, right? So that way if it's empty and they click on it, it will put their piece inside of it. We're going to create a function called toggle cell to do that. But when we kill the game, we basically want to stop them from being able to click those. There's a few different ways we could do that. We could disable everything, right? Or the easier way to do it, actually we have to do it this way because even disabled, it would still work. What we'll do is we'll actually remove our toggle event, okay? This is a bit advanced. Just follow along and we'll get there to the end. Remove event listener. And that takes 2 arguments, click, and the name of our function that we want to remove. The first argument it takes is the actual event that occurs. So this event is a click event. So when the person clicks the element, right? And the next is the function name. Really like silly. I wish I could just call remove event listener and it would just remove all the events that are currently attached to that particular thing. But you can't. You have to literally remove it the same way you added it, which feels really ridiculous, but whatever. All right. Next, we're going to actually set an attribute of disabled. If I can spell it. That's step 3. Then on the game board, we're going to access the class list property of the game board. So the game board is that section element that we had in the HTML. We're going to access a property of it called class list, which is literally a list of the classes that are attached to it. And we're going to add one called game over. And then last but not least, we're going to access our message element and change its text content to equal game over. That's our kill function. There's a lot of logic here. What's the best way to do this? 6:30. Let's try to see if we can get through evaluate board so we don't have to do so much next week. Does anybody need to still see that, or can I scroll down? Good? All right, let's scroll down. Step 4, create an evaluate function to assess if the game is won or in a draw, right? Because there's really only 2 states. There's winning and there's drawing, right? Obviously, if this person's won, the other person's lost. That's inevitable. You can take that for granted, right? It's an implicitly implied. Whereas actually winning the game is the thing that you need to acknowledge, and drawing the game is when both players can no longer lay pieces, but nobody's actually won. Those are the only 2 events that we really care about. So the function that we're going to create, we'll call it evaluate board. Okay. And then the first thing we're going to need under step 4a is a way to keep track of the current pieces that are on the board, the number of pieces that are on the board. So we're going to create a variable called let board full equals 0. So currently there's no pieces on the board, which is correct. That's our beginning state. Under step 4c, we're going to iterate through the win conditions using the newer ES5 method for iterating through a loop. So remember that wonderful for condition I told you about that I was so super crazed about? We're going to use that. So for let win of win conditions, that beautiful thing. Make sure you take off these closing curly braces, because we'll have to add them later on down. And then in ES5, we actually got this thing called destructuring available to us. And destructuring is really, really interesting. In PHP, there's a method called lists. Anybody ever used it before, the function called list? No? List is really interesting. This is really interesting. Basically, what it allows you to do is it allows you to take an array, take all of the elements of that array, and immediately assign each element to a variable, to its own variable. And the way it works is the left side has to be the name of the variables, which you put in an array. So we're going to call it I1, I2, and I3. Okay. And then the right side has to be the array you want to assign. This is another one of those silent fails. If win does not contain the correct number of elements, one of these three will wind up undefined. So that is a very silent killer for sure. Destructuring is really cool. We're actually going to look at destructuring next week. No, the following week. No. Yeah, the following week. We'll be looking at destructuring. We're going to look at a lot of very cool things. All right. Now we're going to do it again. We're going to use destructuring again. We're going to let C1, C2, and C3, C3, not CE, equal. And I'm just going to do this on multiple lines just because it's easier to follow, I find, when it's on multiple lines. Cells I1, cells I2, and cells I3. And you might be like, okay, well, what is that exactly? So the first thing we've done is we've taken one of the win conditions from our win conditions array, right? We have 8 win conditions, I think. I don't know, however many there's. We take one of those win conditions, we assign the values in that win condition, which are the index numbers, right? That's how we're basically defining our index conditions. We're just defining them by index numbers. And we assign those index numbers to here. So the first time we iterate through will be 0, 1, and 2. The top row is the first win condition. I1 will be 0, I2 will be 1, and I3 will be 2. The next thing we do is we actually go and grab those cells from the page. So we go cells I1. We're actually plugging the index number directly into cells, which in this scenario will be 0, which will be this guy right here. Then we get 1. That's this guy here. And then 2, that's this guy here. It pulls back those 3. And the reason why we want to pull them back is because now we want to go and see whether or not there's pieces in them. And if there's pieces in them, are all 3 of those pieces the same? And if they are, who do they belong to? And if that person belongs to them, they won. That's basically what we're doing. And we're doing that through every single win condition we have. So we go through all 8 of the win conditions, and we do the same thing with all 8 of the conditions. We check all the cells to see whether or not that person is won. That's essentially what this is doing. All right, next please. Evaluate if the 3 variables actually have values. We want to see if these guys have any values in them or if they're just blank, right? So we can use .length to figure that out. We can go C1 .length is greater than 0 and C2 .length is greater than 0 and C3 .length is greater than 0. That tells us whether or not these 3 things actually have values inside them. Right? Because, like I said before, with strings, they work the same way as arrays. They're just an array. They're a character array. When we check .length on the string, it tells us how many characters are inside that string. If the string is blank, There's no characters, right? Which means there's no piece in that cell. Next, we want to check to see whether C1 is equal to C2, and if C2 is equal to C3. Right? What is this going to tell me? If that is true, if that statement is true, what does that tell me?
They're all the same.
Yeah, that all three cells are identical. Right? Which means, if all three cells are identical, what has happened in the game? Somebody has 3 in a row. Somebody's won.
I
Right?
don't know if there's like board's full.
What if the board is full?
Yes, that 4G, if they do have one.
The draw.
Yes, we're going to add one inside the if condition to the board. So we'll do that in 1 second here. Oh, wait, no, you're correct. I totally missed that step. Thank you. It's Virginia, right? Yeah. Sorry, we need board full plus equals 1 above that statement. And then that statement actually needs to move down there. My apologies. I missed a step. The board full is basically every time it does this iteration and checks, it's going to add 1 to the board, which will tell us eventually whether or not the board is completely full. All right, we are on step 4I. If so, inform the player who has won, right? Because we established that that's a win condition. So h1.textContent equals, and we might as well use string interpolation with the dirty backticks. Player, we'll add in an expression in there, wins. And then inside here, we'll call current player. But we need to do something to current player in order to say player 1. What do we need to do to current player to say player 1? Add 1. Because we're storing the index number inside current player. Once we're done that, we can kill the game. So we'll literally call our function kill game. Players 1, we're done. We don't need to do anything else. Just kill the game. And then we're going to return false at the end of this just to prevent the toggle event from changing the message. I was having an issue where the toggle event was changing the message. So we have to return false to stop that from happening. All right. Close, close, close. 3 curly braces. It does feel satisfying. What are we at? 640? Yeah. Why don't we pause this then? Okay, we're going to pause this and put it on to the beginning of next week, and we'll complete steps 4L down through to step 8, I think it is. I can't remember what step it ends at. 7G. So please save this. Make sure you have it saved in the spot where you can retrieve it next Tuesday. I will leave it on my desktop so we start at the same spot. If you want to jump ahead, this code is currently sitting on GitHub. You're welcome to look at it, and I will show you kind of what it looks like when it's completed. Dropbox, Georgian comp, 73, week, lessons, week 3, Tic-Tac-Toe. And we will, this live server thing, I will show you this in a few weeks on how to do this. This is our Tic-Tac-Toe board. Okay, this is with an opponent already installed. Click, opponent puts in his O. We'll go here. Ooh, let's try here. Oh, tricky opponent. Here, nope, here. No more moves. And then you can reset the game. The opponent code I'll just be giving you. Because it's pretty easy. That's our AI. AI is in, it only does the same thing every time. Yeah. Yeah, it's on GitHub. I believe the opponent AI is on GitHub too.
Yes, it is.
It is? Yeah, the opponent AI is there. So you can go look at the code. I did simplify it so that it should be, if you're following along further, you should be able to follow it. See what I did? Feel free to modify it, make it better. Yeah, definitely make it better. It has some redundancy in it.